Hello mathematicians, puzzlers, and other curious people. In this video, we're talking about dividing fractions. Now, you may have previously heard me say a fraction is a division problem in disguise. So, taking two division problems and further dividing them? What's that? Okay, well, if you're wondering, let's get to it. So I have for us here a fraction division problem. 6/7 divided by 2 1/2. Now, before we jump straight into different ways we can calculate that, I want to get an idea about what that means. So here's what I know. If I took 6/7, 2, 3, 4, 5, 6, and divided that by 2, I would get 3/7. Now, on the other hand, if I took 6/7 and divided that by 3, I would get 2/7. So I'm expecting to come up with something that's between 2/7 and 3/7. That's going to help me later on because I will want to have something I can compare with to find out if my strategy worked. So now let's think about 6/7 divided by 2 1/12. Well, if a fraction is a division problem in disguise, one way we could write that should be like this: 6/7 divided by 2 1/12. Well, remember, this is really 2 plus 1/12. I'd like to go ahead and turn that into a single fraction because I don't want to have a mix of addition problems and division problems in this. Well, 2 would be 4 halves, so really that's 5 halves. So what we've got here is we're taking 6/7 and dividing it by 5 halves. Well, now I'm going to think equivalent fractions because I want to simplify this fraction because it looks complicated. I'm going to think about multiplying both parts of the fraction by 7 and by 2. Well, divided by 7 and times 7 should come out the same. Divided by 2 times 2 should come out the same. So what we should get should be 6 times 2, so 12, and then 5 times 7, so 30/5. Now that is hard for me to visualize, and I don't know if it's between 2/7 and 3/7. 2/7, well, 7 times 5 would be 35. So 2 times the same 5 would be 10. Okay, well that is less than 12/35. And then 3/7, 7 times 5, so 3 times 5 is 15. Okay, so 12 is in between 10 and 15. So 12/35 is in between 10/35 and 15/35. So I think this worked. So that's one way you can deal with dividing fractions. Another way is by kind of reverse engineering. One idea that you can use as the true meaning of division is the idea that we're working backwards through multiplication. So just like if we said 12 divided by 4 equals 3, because 3 times 4 equals 12, that means we would like to be able to set up a division problem where if we're saying that 6/7 divided by 2 1/2, time out, I'm going to use that improper fraction form that we noticed, 5 halves, is something. That would be because that same thing times 5 halves comes out to 6/7. Now, the immediate problem we run into here is if we try to say something times 5 is 6, whoa, 6 isn't a multiple of 5. So one thing that can help us here is if we get a common denominator. Well, a common denominator for 7 and 2 could be 14. And then let's try dividing across. Times 2, so that would have to be 12/14, times 7, so that would have to be 35/14. So if we get that common denominator and then divide across, well, 14 divided by 14 is just 1. 12 divided by 35, remember a fraction is just a division problem in disguise, so we can say 12/35 over 1, and then we can just drop the over 1. Well, does that work? So I'm going to do a side calculation to check that of 5 over 2 times 12/35. 5 times 12 is 60. You probably already noticed the spoiler anyway that we saw by our other method this worked. 2 times 35 is 70. Well, then that's 6 times 10 over 7 times 10, 6/7, just like we wanted. So we can see that getting a common denominator does work as a method to reverse engineer a factor so that we can think about division as reverse multiplication. Now, all these things we do end up with some multiplication as steps. So some smart person one day said, hey, what if we just multiply what we need to multiply because we already know that that's going to need to be multiplied? Then the person they were talking to about that probably said, well, how do we know, though, which things we're going to need to multiply? I like to think that maybe they thought about a problem like this, and they noticed that they were going to do this times 2 to get rid of this divide by 2, and this times 7 to get rid of this divide by 7. So I think maybe they said, what if we take that 6/7 that we start with, that we're trying to divide by 5 halves, and we say, okay, we know that 6 gets multiplied by the 2, and the 7 up here gets multiplied by the 5. So what if we say, okay, it's like we've got 6/7 times 2/5 all along. So what if we just multiply, but by the reciprocal, and we get that same 12/35? And a lot of people prefer this method because they feel like it's a minimum of muss and fuss. So do whichever method you prefer. Be aware all these methods work, and there are good reasons why they all work. And make sure that you're keeping in mind that the real meaning of division is going to be either something like splitting into groups or something like figuring out an unknown side of a rectangle. And for now, calculator.